Assalamualaikum. For the presentation of this lab mini project, our title is The Effect of Time on Electroplating of Coin. This project consists of 3 members, which is me, Muhammad Adam, Anis FARIHIN, and NATASYAH.
The objective for this experiment first to determine the relationship between the effect of time on the amount of metal deposited. Second, to investigate the effect of time on the reading of the cell for electroplating of coin. For background part, the experiment maintains constant current flow, reaction rate, and potential difference between anode and cathode. The solution's concentration remains constant due to the equal zinc oxidation and the reduction rates. Faraday's first law states that the mass of a substance at an electrode is directly proportional to the amount of electric charge carried through the electrolyte. The relationship can be written as M equal to Qm over Fz. Since the electric charge Q is equal to the current I multiplied by time, the equation can be rewritten as M equal to IT M over Fz. This equation indicates the mass of the coated copper coin is directly proportional to the plating time, with longer duration reducing metal ions and resulting in a thicker coating. The apparatus used in this experiment were power supply, stopwatch, copper wire, alligator clips, zinc strips, electronic balance beakers, sandpapers, and copper coins, while the chemical used were 1 molar zinc nitrate, acetone, and distilled water. Next, for the procedure part. First, the copper coin was cleaned using acetone, then the copper coin sat for a while and swirled until it was completely clean. After that, the copper coin was weighed using an electronic balance. Second, the zinc strip was cleaned using sandpaper. Then, it was rinsed with distilled water before use. Third, 1.0 molar zinc nitrate solution was poured into the beaker. Fourth, the zinc strip was clipped to the positive end and the copper coin to the negative end of the power supply using alligator clips. Fifth, the power supply was switched on and the stopwatch was started spontaneously. The experiment was run with a current of 2.30 ampere. 6. The reading of cell was read and recorded. After 1 minute, the power supply was stopped and the copper coin was dried and reweighed. The experiment was repeated for 2, 3, and 4 minutes.
This is the result of our project. 4 different range of time are done. The first range is 1 minute. The mass deposited is 0.3119 gram, 0.5245 gram for 2 minutes, 0.7760 gram for 3 minutes, and finally 0.9042 gram for 4 minutes. This is the calculation on how to calculate theoretical yield and percentage yield. This is the graph based on the result of our experiment that show a linear straight line.
An electrolytic cell was used in this experiment at which we used power supply instead of salt bridge to allow the movement of electron. A copper-based coin used as the replacement of copper electrode. Based on the standard reduction potential table, zinc, which at higher position will be positive terminal and anode, while the coin as the copper will be negative terminal and cathode. The electron move from anode to cathode at which electron migrate from zinc strip to coin. The electrolyte used in this experiment is zinc nitrate, so the zinc ion from zinc nitrate deposited at the coin. Zinc strip will dissolve to replenish metal ions in electrolyte solution to get constant concentration of zinc ion throughout the experiment. The cell reading does not change as the current applied at 2.3 ampere remain constant for all 4 trials following the Ohm's law, at where if resistance constant, the current will be constant followed by voltage. From the data obtained, a straight linear graph was constructed with the mass of metal deposited directly proportional to the time. As the time increases, the mass of metal deposited increases with accepted R² value. However, the percentage yield we got is higher than 100%, indicate that the actual mass is higher than theoretical mass might cause from the impurities of the coin, or the coin was not completely dried when weighed. In conclusion, the objective of this experiment was successfully achieved. Following the reduction potential table, the higher position anode prone to undergo oxidation, while lower position cathode prone to undergo reduction. As the time increases, mass of the metal deposited increases following the Faraday's first law. The E cell value remained unchanged as the value of current constant throughout the experiment because the power supply using the same resistance, thus why current and E cell remain constant following to the Ohm's law.
That's all from us. Thank you for your attention.